All right, CNT120, we're working on Chapter 3. We're finally down to our last address, application layer, your fully qualified domain name. Hopefully you remember from early on, fully qualified domain name, we're talking about a name like dlbrown.hack.edu, the whole thing, host and domain name. The last two parts are the domain name, in this case hack.edu, and the first part, dlbrown, is the actual host. So all that combined together is your fully qualified domain name. Now, there's some structure to this. Fully qualified domain name, as I take a look at dlbrown.hack.edu, would be an actual node on the network. www.hack.edu is actually a web server connected to the hack.edu name. Meanwhile, ftp.hack.edu is a FTP server connected to the hack.edu name. So the first part, that host name, does have some implications. dbrown or dlbrown is an actual node or host. www will be a web server. FTP is an FTP server. And meanwhile, hack.edu is domain for all of those. So there's some structure to this. There's some meaning to this as you look at those. The last part of this fully qualified domain name, hack.edu, is, as I look at this, I saw the www is the web server, hack.edu is the domain, the .edu is the top level domain of .edu, and that becomes important because all domain names are organized, and the top level domain, that last part, is organized into a structure, and there is restrictions on some of these, .gov, .edu, Intel, MIT, ARP, but things like .coms could be just companies. Okay, so there's a structure to this. So here's some well-known top-level domains: ARPA, COM, EDU, etc. Okay, and if I take a look at the top-level domain authorities, if I go to IANA.org, I can actually see, here's IANA.org, I can actually see a database of top-level domains, and I can scroll down through. Here they are. I mean, there's many of them. Okay, there's many of them. Now I'm going to go to .com real quick just to take a look. We know .com is usually a business somewhere. So we go .com, there's .com, and if I take a peek, the top-level domain .com, VeriSign is the company that maintains the authoritative list on this domain .com. And hopefully VeriSign you recognize. They're usually on if you have a secure login somewhere, you usually see their logo somewhere on that site. So there's the top-level domains at IANA. Now, if I go a little further, if I'm going to buy a domain name, I register it with somebody like a GoDaddy. So let me go to GoDaddy real quick and say, okay, I want to register the name networking is cool, and I want to buy that domain name. So I'm going to look to see if it's actually available. Networkingiscool.com. All right, so I'm going to, that's already taken. Let's do networking is awesome. If I can spell it right, A-W-E-S-O-M-E. There you go. Networking is awesome. Hey, that's available. So first thing off the bat, I noticed that the first domain name I tried is taken. The second one is not. And it's saying, hey, it's available. You can buy it for blah. And it's usually like $15 a year kind of thing. They're giving you some introductory rate, blah, blah, blah. Okay. Well, if I say I'm going to buy this, what I end up doing is saying, okay, I'm going to add this to my cart. I'm going to agree. I'll put my credit card in and pay $15 a year or whatever the rate is. And what happens is I then plug in my name, my address, my phone number, and I eventually plug in, this is the IP address of this website. Because eventually I'm going to have people coming to this website, networkingisawesome.com, so it's going to go to a web server. So I plug in the IP address of the web server. Now I have a connection between this domain name and an actual IP address of a web server somewhere in the world. That happens when I buy a domain name. I've done this for my wife's business, and that's what you do, is you buy the domain name and you register that. You also plug in the IP address that's associated with it. Okay? So that is how I would register a domain name. It's really simple. It's really cheap. And that's what companies will do. Well, if I go a little further, I can turn that around and say, well, who owns a particular domain name? We tried one there. We said, well, networking is cool, didn't we? Networking is cool. They said that was taken. Let's go back here and try. What was it? Networking is cool. Yeah, there it was. Okay, let's try something. It's not what I had on my page there, but networkingiscool.com. Let's try something. Let's go here. I was going to do a hack.edu, but let's do something a little bit more fun now. Let's see if we can do networkingiscool.com and see who owns that. No, I'm not a robot. Okay, take me to where I want to go. Storefront. Storefront. Okay, those look like storefronts to me. Verify. Okay, looks good. Now we're going to see who owns this. Well, this is owned by some entity in Cambridge, Massachusetts. I keep digging. Well, this is a bunch of the information that's plugged in when they bought this domain name. Keep going. I would eventually find down here, I hope to find down here, some more information about it. Okay, here is some addressing information on their DNS servers, but okay, there's some who it belongs to and where it's located in the world. So there is a real quick, because you register a domain name, you can do just the opposite, who owns it. Well, I'm also going to do a www.hack.edu and see who owns that as well. Well, we know who owns that, but I'll do it anyway just to pull up the information. Here is hack.edu. There's the domain name. It belongs to Harrisburg Area Community College. Here's the addresses and so forth and context, and here's the name servers, when they activated it, and when it expires. And that is something that needs to be renewed every year. It's something I renew for my wife's business every year. Gives you a warning about a month or two ahead of time, and then you can jump in there and buy it. If not, somebody else could buy it up. It's legit that happens. Annoying, but it's legit that happens. Somebody else could buy your domain name. And that's because when I bought the domain name, I had to plug all the information in, and I can reverse that and say, well, who does this belong to? Because all that has to be registered. Now, the last podcast, we actually did a Wireshark of DNS to show you DNS is actually talking to the DNS server. DNS server responds with, here's the IP address you were looking for. Hopefully you remember that. That is key to this. That is key to this. That is a process. So, in the process of doing this, it basically, DNS says, okay, what's the IP address for? So I ask for, hey, what's hack.edu? The DNS server responds with, hey, here's the IP address for hack.edu. That's the idea behind the DNS server. Well, this is a process. This is a system, if you will. It's an application layer protocol that's going to query a database that has these things, that has a namespace, name servers, and resolvers. Namespace is just that. Collection of computer names and their associated IP addresses in a database. Name servers are the actual servers that are holding that database. And then resolvers are the clients that are talking to the DNS server and getting responses back. And you do have primary DNS servers, secondary DNS servers, caching DNS servers, and forwarding DNS servers, all serving a role in this process of getting you name to IP address mapping. Name to IP address mapping. Here's the structure of DNS servers, and this gives you root servers here, down to .coms and then individual entities and .coms. Or over here in .edu, we'd have hack.edu would be part of this structure as well. Well, at the root, there's 13 clusters of root servers. And out of fun, I do this for you. I'll back up on this right here and go back to, hey, give me the root servers. Actually, I think there's a link right here. I'll use this link. On IANA, here's the root database. Actually, let me go here. Let me go back to our home. Here is the database root zone management. Here's your root servers, root zone database, and then in there here's your root servers. Actually, no, that's still not what we're looking for. All right, hold on here. Let me go back to here. And actually, I think I have it listed here. There you go, root servers. Domains.root servers. I want to make sure I'm in the right spot for you. Domains.root servers. It's not coming up there. Root/servers. That's what I want. That's what I want. We'll go that way. There's your root servers. Oh, I think the link was right there and I was looking right by it. Oh well, here's your root servers. These are the authoritative root servers for the whole DNS structure. So these are the ones that are go-to for any kind of resolution issue. If you can't resolve it, these will be the ones that are connected at the root level. Okay? And these are scattered kind of strategically around each of the coasts, if you will. They're the authoritative servers for IP address and computer names. Now, coming down a level, actually, excuse me, I'm sorry, I jumped by the top level domain servers are the authoritative for their domain. So there's authoritative server for .com, there's an authoritative server for .org and .edu and so forth. And if I take a look at, this is the root database we had looked at earlier, if I go here to the root database and go to .com, we'll find out that VeriSign is the authoritative entity for the .com domain, top level domain. There it is, VeriSign. .edu is EduCause. Here's .com, VeriSign, .org, Public Interest Registry. .edu is EduCause, and so forth. Authoritative servers hold the database for that domain. So the hack.edu DNS servers. The hack.edu's DNS servers would have the authoritative list for hack. And they would know where all the host names are for devices in the network. The structure itself works like so. If a client has a name they need to resolve, they're going to hit the local DNS server, and it's going to start hitting servers root, okay, then top level domain, then authoritative. So it'll try the top level of the tree and then work its way down until it can get the exact IP of what it's looking for. It's a process. And then hopefully if it's done that, it's going to maintain that it doesn't have to ask for that in the future. And that's where when they looked at the caching, the primary, the secondary, and caching, these DNS servers have a different function. They would maintain a list of this so it doesn't have to ask for everything all the time. There's two different requests. There's recursive and iterative. And these are recursive, like, hey, I need a resolution. The iterative is like, try your best. If they have it, okay. I'm not going to demand a resolution. And try to find that. There's different records on your DNS database. A record for IP version 4 mappings. Quad A for IP version 6 mappings. CNAME for alternative names for host. Pointer for reverse lookups. NS for name server records. This indicates the authoritative name servers. MX is for mail. Where's the mail servers? SRV or service records host a specific service like FTP or SIP. And text holds additional type of freeform text that sometimes gets referenced. And here they give you examples. This actually, the chart gives you a pretty good example of these different records on the DNS server. I'd recognize at least the main types of. The two main types of DNS server software are Bind and Microsoft. Microsoft has the DNS server as well as Bind. Bind is a open source, Linux-based, freely available DNS server, and then Microsoft has its own DNS server. And they talk about, with that, you often create a DMZ, and that way traffic coming out from the internet comes through your firewall, hits the DNS server to direct things to certain entities inside your network and or out. Okay, usually for traffic coming in the DMZ, it hits it and says, well, I need you to go here, I need you to go here. And the firewalls are controlling where it goes to. So there's a quick overview of DNS. We'll come back in the last podcast on troubleshooting.